Hello students, in lecture number 8 I am going to give answers of the queries that you have sent me on my email. So first I will be addressing the queries regarding lecture number 4, and lecture number 4 is about even and odd signals and periodic and aperiodic signals. So the first query that I have received is from Mr. Shaheen Iqbal, and he is asking about, does it always consider to be slope and the constant value to be offset even if the constant comes first, for example 2 minus t. Yes, I mean the slope and offset are two different things. Slope is whatever is multiplied with t, and offset is whatever is added with t. Right? So if it is, for example, 2 minus t, then 2 is offset here, and minus t means minus 1 is slope. It means it has negative slope, it is decreasing ramp. And if it is for example 2 plus t, again 2 is the offset and slope is positive, it is increasing ramp. And I believe this query is regarding the example that we solved in lecture number 4, in which we decompose a signal into even and odd parts, and the even part of the signal was this one, right? So here you can see we have even part which consists of three parts: the part where signal's value is 0, right, and the part where signal value is t plus 2 when the time is between minus 1 and 0, and 2 minus t when time is between 0 and 1. So offset is basically the value of function when t equal to 0, right? So when we put t equal to 0 here, the value of function would be 2 in either case, right? However, when t is not 0, this function is actually unit ramp function with offset 2, and this one is also unit ramp function but decreasing with offset 2. If we draw these signals, you can see here when t is equal to 0, both have value 2, and t plus 2 is basically this one, increasing ramp. When time is minus 1 to 0, it is increasing, and this 2 minus t is this one. So when time is 0, it is 2, and when time is greater than 0, it is decreasing with time. So, and also it doesn't matter if we write down this function as t plus 2 or 2 plus t, it doesn't matter. And also here, if we write down this function as minus t plus 2 or 2 minus t, it doesn't matter. I hope I have answered your queries, and if you still have some confusion, you can ask again. This query, the student is asking about the fundamental period. So for fundamental period, for example, if signal is given by this expression, this one, do we divide 2 with the constant part of function? And the constant part of function, I believe what you are referring to is this one, whatever is inside the bracket, not this one, because this constant is basically amplitude, right? And this constant is basically amplitude. So this value, whatever is inside the bracket, 12 pi t, yes, we have to divide it by 2 in order to find out the frequency. And why we divide it by 2? Because if we compare this with the general expression a sine 2 pi f t and 12 pi t, right? If you want to find out the frequency, you have to compare this entire value to this value, right? And we compare this value, then obviously you have to divide by 2. And if you want to find out the fundamental time period, you have to multiply. Next query that I have received is regarding exercise problems I gave you in lecture number 4, and particularly the part B of that exercise. In this exercise, a function is given, and you had to determine whether this function is periodic or not, and if it is periodic, then what is the fundamental period. So the function here is g of t equal to 3 plus t square. So in this function, when t equal to 0, the value would be 3, and when t is non-zero, the value would be 3 plus something else, right? So obviously this function is not periodic, it would never repeat itself, and whatever the value of t we put, it would always be increasing. For example, here value of t is -1, so square of -1 is 1, and +3 the value is 4, and similarly it would keep increasing when t is approaching towards -infinity, and similarly when t is going towards positive infinity, it is again increasing. So it would be increasing in the both directions, whether t is negative, or when t approaches towards -infinity, t approaches towards positive infinity. So it would never repeat itself. In fact, it would keep this same pattern which is shown in this figure. Now moving on, so this is the queries of lecture number 5. The lecture number 5 was about signal energy and signal. Now the first query that I have received regarding lecture number 5 is this one: when exactly modulus of the signal is used, and what are the parameters to sketch the modulus of the signal. In this query, I believe the student is referring to the energy formula that we used. So we have this energy formula to compute the energy of a signal when signal is real, and this is the formula to compute the energy of the signal when x of t is complex. So when x of t is real, simple square is enough, right? Because taking simple square of a real signal would convert the negative part of the signal into positive, right? But when the signal is complex, for example this one, x is equal to a plus jb, where a is the real part and b is the imaginary part, and if we take square of this, you will get a square plus 2jab minus b square. So it still have this negative part, right? So in order to address this issue, instead of taking square of a complex number, we take modulus. So modulus is basically square of the imaginary part and square of the real part into the square root, right? And when you take square of the modulus, you will get simply a square plus b square, and in that way you can see it doesn't have any negative part. This function would never be negative, right? Whatever the values of a and b are. So that is why when the signal is complex, we take modulus first. In next query, a student is asking, real physical systems respond to the energy of an excitation. Can you please explain this statement? The excitation is nothing but it is the input that we apply to the system. For example, we apply electrical voltages to the input of a DC motor, we apply torque to the wheels of the vehicle. These all carry energy, that supply energy to the system, and eventually it excites the system, and system then responds, right? So excitation is nothing but it is another name of input. So when you apply input to the system, obviously the system responds, the system produces output. The simple example of that is the DC motor. You apply electrical voltages as the input, and these electrical voltages actually excite the internal circuit of the motor, and motor actually start to rotate, and it is actually the response of the motor when you apply electrical energy at the input, and the response produced is the mechanical output. So the next query is about how do we determine that the signal has infinite energy and finite power. So the simple answer for this question is that those signals which are not time limited have infinite energy. For example, let us consider this simple sinusoidal waveform as x of t equal to sine 2 pi t from -infinity to infinity. So it is an infinite waveform, a periodic waveform, and if we compute the energy of this signal would be infinity, because it is infinite waveform, it would carry infinite energy. So in those cases, what we do, instead of computing energy of entire signal, we compute energy per unit time, which is called power. So we compute average power for any one time unit, for example for one cycle, right? So the t here is the time period of the waveform, and we compute energy of the signal for one cycle, right? So let us compute the average power of the signal given in the previous slide, which is sine 2 pi t, and you can compute the average power by taking any one cycle, one complete cycle, for example from -1 to 0 or 0 to 1 or 1 to 2, whatever, right? So I am taking one cycle from 0 to 1, so time period of the waveform is equal to 1 second, and substituting the values in the formula, the integral limits are from 0 to 1, and the integral of sine square 2 pi t would be this one. After substituting limit, you can find out the average power, which came out to be pi. So that is end of the queries, and if you have more queries, you can send me an email given in the first slide of this lecture. Thank you very much.